Hello, and welcome back to this ElasticSearch tutorial. In this part, now that we've already set up and configured our ElasticSearch instance, we'll learn a little bit about the ElasticSearch field types or data types. Just like any traditional RDBMS or database manager, ElasticSearch has different data types available for our fields to use. This changes how we store our information and how we retrieve it later on. In general, ElasticSearch data types are divided in 4 core data types, which would be your primitives in a programming language, or the basic data types. Complex, which are, like the name suggests, more complex data types and can be composed of objects made up of the other data types. Geographical data types, which are used for storing geographical information for use later on and have special attributes in order to make geographical searches easier, for example, searches by proximity, and specialized data types, which are any other data type that doesn't fit neatly into the other 3 categories. Starting with the core data types, we have something that will look very familiar if you're used to working with regular databases. We have string data types, numeric, date, boolean, binary, and range data types, very similar to what you would have in a traditional database. For string data types, we have 2, text and keyword. Text is used for storing full text values, and they're passed to an analyzer that converts the string into tokens before being indexed. This is the main difference with the other string data type, keyword, which is not tokenized and not analyzed. For example, if you have a field called description, and in that description you want to search for a specific word, you would use a text data type rather than a keyword data type, because text will allow you to search for one of the words within that description, whereas keyword will force you to search for the complete description in order to find a match. This is useful if what you're looking for actually has to be an exact match. For example, a zip code or an email address. On the other hand, A text field is more useful when you want to allow users to search for a fragment of the whole text. For example, within an excerpt, you would allow users to search for France if France is mentioned anywhere within the excerpt. Next, we have numeric data types such as long, integer, short, byte, double, float, half float, and scaled float. Integers allow you to store only integer values, that is, values without decimal points. Long and short also allow you to store integers, but they change in the amount of digits that you can add. Long is 64 bits and short is only 16 bits, so you can store shorter values with those. Byte is also an integer value, but only 8 bits. Double, float, half float, and scale float all allow you to use decimal points. Next, the date data type allows you to store a date that will internally be converted to UTC, or the Universal Time Zone. Dates can be one of several formats. They can be either a formatted string, for example, 2019, July 18, or they can be a long, representing how many milliseconds have happened since the start of the epoch, or an integer representing how many seconds have passed since the start of the epoch. Then there is the date nanos data type. This is almost the same as date, but uses more precision when storing dates. Date stores up to milliseconds, whereas date nanos stores up to nanoseconds, which allows you more precision but less dates, roughly from 1970, which is the start of the epoch, to 2262, since you are using part of your storage for the nanoseconds. Boolean data types allow you to store only Boolean values, that is, true or false. Binary data types allow you to store base 64 encoded strings, although by default those fields are not stored and not searchable. Finally, range data types are used for storing ranges of information. Those can be either integer ranges, float ranges, long ranges, double ranges, or date ranges. Next, complex data types are JSON objects, either a single JSON object, which is the object data type, or arrays of JSON objects, which is the nested data type. Objects, either single or nested, are a collection of key value pairs where the value can be any of the other data types that we just mentioned. Or it could be an object in itself, which is another collection of fields. Geodata types are a very useful feature of Elasticsearch because they allow you to store a geographical point, such as an address, in Elasticsearch and then search by it. For example, imagine that you are storing the addresses of your stores and you would like to show your users the closest one. Elasticsearch allows you to search by your current address or your current position with the positions stored within Elasticsearch and show you the closest one. The difference between GeoPoint and GeoShape is that GeoPoint is a latitude and longitude pair, and it represents a single point within a geographical map, whereas GeoShape allows you to store several points in order to create a shape, such as, for example, a neighborhood delimiter or a zip code. Both of these are useful for searching within a certain distance. Finally, specialized data types are a very specific type of data, such as token count, which stores how many tokens there are within a string, IP, which is used for IP addresses, either IPv4 or IPv6, and allows you to search for proximity of IP addresses, completion, which is used to provide autocomplete suggestions, which is what shows up when you start typing in a website, for example, alias, which is used to define an alias to another field to be able to call it by that other name, rank, which is used to boost how this record will show within the searches, among others. Now that we have a basic overview of the data types available within Elasticsearch, in the next part, we'll take a look at the document API and the things that you can do using it.